Okay, looking into absolute value inequalities. Again, absolute value is the distance away from zero on a number line. That is the total number of integral units away from zero, and tying in together an absolute value equation concept with what we have in the case of inequalities. All right, we have with the rules of thumb, okay, we have that if k is a non-negative value, and we have, first of all, the absolute value of x is equal to k, then we have x is equal to plus or minus k. All right. Now, where the inequalities begin, if k is non-negative, and we have that the absolute value of x is less than k, then we have that negative k is less than x is less than k. And if I were to express this statement in terms of interval notation, we would have the use of parentheses to enclose negative and positive k. Now, if we have the statement to be where the absolute value of x is less than or equal to k, we have almost the same type of inequality. In fact, we do have a compound inequality, but with the equal signs included, okay, we have negative and positive k as parts of the solution. So we have the lower and upper limits to officially be minus and positive k. All right, and in the interval notation, again, we have the enclosure to be brackets. All right, so for the absolute value of x is greater than k, okay, we'll be going in opposite directions. For x, okay, it might be that on the minus side we have x is less than negative k, or x is greater than. For the interval notation, we have on the side of x is less than negative k, so we have parentheses around negative infinity and negative k. And we have for x is greater than k. All right, we'll have for our other interval solution portion, we have parentheses going around k and infinity, and the notation that you have in the middle, that U symbol, this is in reference to the union of intervals. Now, when the absolute value inequality is stated such that the absolute value of x is greater than or equal to k, then we have x is less than or equal to negative k, or x is greater than or equal to k. And if I were to express in interval terms, so we have going from negative infinity, approaching and including negative k. So we have the bracket around negative k, and for x is greater than or equal to k, the equal signifies that we'll have a bracket around k, and we have going on out to infinity. All right. Now, for dealing with inequalities, now if we're looking for the values of x, and let's say that for our first statement, we have 2 times the absolute value of x minus 3 plus 4 is less than 10. Okay, so if I isolate the absolute value of x minus 3, again, you do not treat the absolute value symbols as you would parentheses. So we're not going to distribute 2. So we're going to proceed, again, by subtracting 4 from both sides. So we have 2 times the absolute value of x minus 3 is less than 6. And in the next step, okay, we're going to isolate the absolute value of x minus 3 upon division by 2. And dividing both sides by 2. So we're going to have the absolute value of x minus 3 is less than 3. Now, this is optional, but just for visual references, okay, if I were to take the graph of x minus 3, okay, again, the absolute value of x minus 3 is less than 3. Now, again, we have the centerpiece regarding absolute value is 0. Now, we have our numbers that will have an absolute value of 3. Okay, we have one is 3, and of course the other is going to be the additive inverse, which is negative 3. And again, if the absolute value of x minus 3 is less than 3, that means that whatever distance x minus 3 is away from 0, it's going to be less than 3 units. So you're going to have x minus 3 to fall between negative and positive 3. And since we're looking at less than 3, we're going to have open circles or parentheses at negative and positive 3. And taking what we have now, say, in the graph of x minus 3. So x minus 3, again, you have situated between negative and positive 3. And transitioning from the absolute value inequality to an inequality. Now we're going to have, in this setting, we're now going to have that negative 3 is less than x minus 3, which in turn is going to be less than positive 3. And if we look at isolating x, we're going to have for all portions of the compound inequality, we're going to add 3. And for the resulting inequality solution, negative 3 plus 3 is 0. In turn is less than x, which in turn is less than 6. And if I were to express what I have for x in interval solution terms, okay, we'll have for the lower and the upper limits, okay, they will be tangent to 0 and 6. And since both portions of the compound inequality contain less than, we have the enclosure of parentheses around the 0 and the 6. Now, another case we have for the second item, now we have negative 3 times the absolute value of x minus 5 plus 4 is less than or equal to 8. And if I isolate the absolute value term, okay, so I can take away 4 from both sides, so we have negative 3, and I have times the absolute value of x minus 5. And upon deducting 4, so we have negative 8 minus 4, so this will be at negative 12. And we have in the setup, we're going to be looking at division by negative 3. And if I multiply or divide by a negative, not add or subtract, but multiply or divide by a negative, what is going to happen is that the direction of the inequality is going to change. And so upon division by negative 3, okay, the inequality goes from less than or equal to greater than or equal to. And so we're going to have in the rewrite, we will have the absolute value of x minus 5 is greater than or equal to 4. And in taking what we have here, so we have for the absolute value of x minus 5 is greater than or equal to 4. All right. And again, we have with our numbers that have an absolute value of 4, we have both 4 and negative 4. And now, so we have with the absolute value equal to 4, and we have solid points on both negative and positive 4, and increasing the absolute value. So we're going to have, in this particular case, right, we'll have rays that will end up going at the maximum end, you have going out to the right. And then we have at the minimum, okay, we're going to have a ray that's going to go to the left. And expressing what we have here in inequality terms, and we have upon removal of the absolute value symbols, okay, so we have at the lower end, we have the x minus 5 is going to be less than or equal to negative 4. And we have at the upper end, we have x minus 5 is greater than or equal to positive 4. And in looking at isolating x, I have upon adding 5, and we have with the distinct inequality solutions, okay, so we're going to have at the lower end, we're going to have that x is less than or equal to 1, or we're going to have the x is greater than or equal to 9. Okay. And for what we have in interval solution terms, okay, for x is less than or equal to 1, okay, so we have this case. All right, so we have negative infinity up to and including 1, since we have the equal sign, and then we have or, and for x is greater than or equal to 9, so we have going from and including 9 on out to infinity. And again, our infinities, positive and negative, remain in parentheses. All right. Now for the next two inequality statements, say we have in the third case, for the absolute value of x plus 7, followed by the addition of 3 is less than 14. If I isolate the absolute value expression, okay, we have upon deducting 3 from both sides, so I have the absolute value of x plus 7 is less than 11. And taking what I have here, and we have with our numbers, okay, with an absolute value of 11, so we have 11 as well as minus 11, and in taking what we have now, again, so you're looking at x plus 7 is going to have a distance of less than 11 units away from 0 on the number line. So we're going to have that x plus 7 is going to be situated such that negative 11 is less than x plus 7, which in turn is going to be less than 11. And so setting up the compound inequality and looking at isolating x, so here we're going to take away 7 from all portions. And we have negative 11 minus 7, so we have negative 18 is less than x, which in turn is going to be less than 4. And we have, okay, for the interval solution that corresponds, so we're going to have, in this one we have negative 18 and 4, and for the lower and the upper limits, okay, they're going to be tangent but not including negative 18 or positive 4, so we have the use of parentheses exclusively. Now, for what we have in the remaining case, all right, if I'm isolating the absolute value of x plus 1 in this statement, okay, so I can take away 5 on both sides, so we have transitioning, we have negative 2 times the absolute value of x plus 1 is greater than or equal to negative 12. And again, we are re-entering the zone of dividing by a negative. And once again, if you're looking at dividing by a negative, we're going to have the direction of the inequality to change. This time going from greater than or equal to less than or equal to. And so we have with division by negative 2, we're going to have, in this case, right, so we have the absolute value of x plus 1 is less than or equal to 6. And in taking what we have here and concerning the absolute value of 6, right, so we have at the lower end, we have negative 6, upper end, okay, we have positive 6, and in terms of the dynamics that will play out, okay, so you have the absolute value of x plus 1 is less than or equal to 6. The equal sign indicates that we're going to have solid points on both negative and positive 6. Everything else in x plus 1 is going to have a distance of less than 6 units away from 0. Okay, and so we have in the setup, okay, so we're going to have x plus 1, again, to be situated between negative and positive 6, and expressing in inequality terms. So we have a compound statement whereupon we have negative 6 is less than or equal to x plus 1, which in turn is going to be less than or equal to 6. And upon taking 1 away from all portions, we have in the inequality solution, we have negative 7 is less than or equal to x, which in turn is going to be less than or equal to 5. And so we have with our interval solution, so we have with negative 7 and 5, we have the enclosure of brackets.